If you notice here, we have two autonomous systems, 130, and it is dual homed. Let me cut this picture off so that I can write. Yep, it is dual homed. Our target is this network. Let's see, wait, let me go through this. This is router 3's loopback. Where is router 3? It's here, 6.6.6.6. And also we have another loopback, 7.7.7.7. Sorry, it's not loopback, it's Ethernet. It's okay, it can be a loopback also. Now we have a serial interface 13.3, which is this, and then the other serial interface 23.3, this one. Now BGP has got two networks to advertise from router 3. We are advertising this both network. So the neighbors are router 1 and router 2. Router 1 and router 2. 10.10.10.13.1 is one neighbor. 23.2 is another neighbor. 23.2 is another neighbor. And if you notice, we have enabled the keyword send the community for both the neighbor. And we are using a route map. When we advertise these networks, we add some community value to it. When we advertise these network, which network? These two networks. How do I know? I know because I have seen this page, but you are going to see in some time the route map, what this peer R1 out means. Likewise, we have another route map, peer route to out. Now what is this route map contain? It contains this. See, there is an access list called 101 which is matching with 6.6.6.6. When that match happens, we are attaching a tag value. 20, another access list 7, we are attaching another tag value. So 300, 250. 300 is for 6.6.6.6. I would like to write here. Towards R1 for 6.6.6.6 our community value is 100.300, 100:300. Towards 7.7.7.7, while sending 777, we are attaching this tag value 100:250. Now let's go down. There is another route map called peer 2 route map, where we are calling 101 and giving 250. 102 we are giving 300, which is opposite to what we did earlier. So towards this direction, when we advertise 6.6.6.6 to this neighbor out, we are saying 100:250. For 777 we are giving 100:300. See, access list 102 matches 777. Yeah, so we are giving 300. Right. Next is, that's all. From the customer side, we are just tagging and sending. This is a customer. Customer side, we are tagging and sending it. To send it, we say send community. Now when R1 receives, it receives with this tag value. When R2 receives, it receives with this tag value. Now action need to be taken in R1 and R2. The meaning for the tag need to be given in R1 and R2.
It's behind that cell, if any other router connected to R1 and R2, so that those will not get those routes based on our policy.
You mean here?
Yes.
They will get. We are not saying no advertise or anything like that. We are just tagging and sending. If this is going to forward, it will get that same tag value. But it should be EBGP. See, it is only between EBGP. It is only
no export, then it will not send anything.
Correct. Let's not get into that. That is well-known community. This is different. This is custom community. Don't mix this and that. So now the purpose of this is different from what we saw in the previous class. The previous class we are just trying to use a well-known community like advertise, internet, no export, something like that. But here we are giving our own tag values instead of saying no export. When you say no export, a tag value something like this will be dynamically given. Here we are not doing that. We are giving a custom number so that we can have a custom path tuning using community value. See what happens. On R1 is an ISP on the top. We are asking R1 to match. We say IP community value 1 for this 100:300. We are giving an ID on router 1, and for 100:250 we are giving an ID 2. So let us go to the picture. We are setting 1 for 100:300, 2 for 100:250. Why are we doing this? You will know. We cannot call this under the route map, so we call this number in the route map. So we have defined this, right? Now you see, under the route map, pairing with router 3, which is down router, the customer router, if the community value is 1, which means this one, 100:300, you make R3 as the preference router, preference level 130. If it matches with 2, you are giving 125. So, you are setting preference value. So here the preference value is 130. Here the preference value is 125. Local preference. Let us go and see what is written in router 2. In router 2, same 1 means 300, 2 means 250. We are giving one 130. Same what you configured there, but for 2 you are giving something very big. I think this must be a mistake. It cannot be 8. It's 125 only. Mistaken. So it's the same configuration. Understand? 1 means 130. 2 means 125. I already told you, 1 is mapped to all the tagged traffic that is coming in with 300. 2 is a mapping number for all the tagged traffic that is coming with 250. Now, if a packet comes from the top, goes to this router and this router, there are 2 paths. There is a router here. Let me say IBGP. No need of eBGP. We have an IBGP router. The traffic is coming from here, whose destination is 7.7.7.7. Which router the packet will go? Will it go via router 1 to the customer, or it will go to customer via router 2?
R1.
No, it will go via R2. Listen carefully. 100 colon 300 is 1 here. If it is 1, high local preference, which means this router for 777 it is 130. For 6.6.6.6, which is 2, see, tagged and sent as 250, which is 2, for which the local preference is 125. Whereas on router 1, for 6.6.6.6, which is matching with 300, local preference is 130. For 7777, local preference is 125. So what I am going to say is, local preference is advertised to all the internal routers. So this router, what it will think, I should go via router 1 if the destination is 6.6.6.6. I should go via router 2 if the destination is 7777. Because for 777, local preference is 130 here, here it is 125. You see how the community can work. If you watch this video 2 or 3 times, you will understand more clear.
Sir, when we will have that lab for this, then we will have a more clarity, sir.
Yeah, we are going to have lab now.
Okay.
Right, so you will have more clarity when we have lab, that's true. Still, if you are not clear, you will have this recording. Let me bring this topology up. 50, which will be matched with 2. will be given local preference of 500. So here 6 is matching with 1000, so it is given 1000 local preference. Here 7 is matching with 1000, 7 is given high local preference. So when I send the community towards R1, I need to say 100:100 for the network 6.6.6.6, 100:50 for the network 7.7.7.7. Whereas here it is the opposite. Here it's going to be opposite. This is going to be 50. 7 is preferred here, so this is going to be 100. Now you try to understand community, how it is going to work. I have put the maximum in the presentation now to explain you how it works. I put the maximum. Let me explain it one more time with this. You see, while advertising this 66666 network, I am tagging with 100. For the same 6.6.6.6, I am tagging towards the other neighbor as 50. And towards the left, 7 is having 50. Towards the right, 7 is having 100. Now what happens here is, anything that is matching with 100 is 1 community value. The community ID is 1. Anything that is having 1 will have 1000. No, I'm sorry. I'm making a mistake. Anything that is having 1, right here. 50 is given 2. Here also 50 is given 2. 2 will have 500. No, that should be different. If this is what going to be sent, then I need to change it here. 2 here, 1 here. Let's see this example, what they have done. You can do it in various ways. Here 2 is 250. Which one? Router 3. Sorry, router 2. Router 2 is 250. What about router 3? Sorry, router 1. Router 1 router 1 also 2 is 250. So our way of doing, here also 2 is 50, here also 2 is 50. Okay, fine. Then where the variation happens? If it is 1, here it is given 130. If it is 1, here it is given 130. whereas on the other router same, one is 130. So we are giving 1 means 1000 on both. So sending side only it is going to vary then. One is matching with 1000. If I send 6 will be preferred here. Here also 6 will be preferred. No, 7. This is right. Sorry, I got confused because here I have written upside and down. That's why. So you see here 777 is going with 100. If it is going with 100, local preference is 1000. Here 666 is going with 100. When it goes with 100, it takes 1000. So 66666 is preferred on router 1, 777 is preferred on router 2. Perfect, it's the same. Correctly configured. No confusion here. So let me repeat once again. We are tagging like this and sending to upstream. R3 when it sends to R1, 6 is tagged with 100, 7 is tagged with 50. While sending to R2 it is opposite. 6 is tagged with only 50, whereas 7 is tagged with 100. Now if it is 100, we put 1. Here also you see 100, we put 1. 50 we put 2. 50 we put 2. And we are saying if it is 1, give 1000. Both. If it is 2, give 500. So on the ISP side there is no change. ISP, according to ISP, any destination prefix advertisement comes with 1000. I need to give 100. I need to give 1000. Anything, any network that comes with 100, I'll give 1000. To router 2, 777 is coming. So 7 is preferred on router 2. To router 1, 66666 is coming with 1000. So router 1 is preferred. That's simple it is. I'm going to do it now. Interface G3/0 13.13.0.3. Router BGP what 300 neighbor it is 1, it's not 2 here, it's 1 here. Remote AS is 124. We got another neighbor 23.23.0.2 remote AS 124. We are going to advertise the network. Yeah. Network 6.6.6.6 mask. Network 7.7.7.7 mask. . . 。 . 。. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . and write to memory. This is without commurity. I'll paste this on router 3. Save the configuration. Now let's move on to router. I'll go to router 4 now. Router 4 4.4.4.4 F 0/0. IP address is 10.142.0.4, and then there is no other interface needed. I'll remove this. Neighbor, the local AS is 124. The neighbors are 10.124.0.1. Remote is the same, local 124. Another neighbor is 10.142.142. .2, and then we have a network to advertise, which is 4.4.4.4. Select all, copy, paste it. Now 2 more routers. On router 2 I don't want to have any loopbacks, so I'll change this as interface. Interface G3/0. The IP address is 13.13.0.1.255.255.00. No shit. Interface F00 will be 142.1. BGP 124. I got 2 IBGP neighbors, 4 and 2. And then one more neighbor. BGP 13.13.0.3. Remote AS is 300. Not neighbor, not network, neighbor. End. This goes on router 1. Next on router 2, G00 will be 2323. dot 2 here. Neighbors are 1 and 4. This I'm going to paste it on router 2. Alright, so final test, I should ping from router 4. Let me ping from router 4. Ping 6.6.6.6. I'm pinging with the source 444 because this is what we advertised. Which means the route has not come. Let's wait. The reason may be the next up self. You need to give next up self. R1 do not know, R4 do not know about this 13 and 23. So we need to go to router 1 and say next up self. Router BGP 124. The neighbor, this one, next up self, and then 4. Clear IP BGP star soft. Likewise, on R2, router BGP 124. Right. Now what we are expecting is reachability from R4. Let me try now. See it pings. I can ping 6.6.6.6 from loopback 444. I can also ping 777. When I trace route, you will find for both 6.6.6.6 and 7.7.7.7 it goes via the same path. See, it goes via router 1. It goes via router 1. See, show IP route BGP. It shows via router 1 only. It's not going via router 2. Sorry. Our aim is for 7 it should go via 2. Here I should see 2 next time when I see the routing table. For 6 it is okay. That is our aim. In another word, if I need to say, customer wants packet for 7 to come like this, whereas for 6 he wants it to come via this. In that way we have load balancing, optimizing the path selection. Load balancing in BGP can be done only like this. There is no dynamic automatic load balancing. Right, so let us begin our configuration. I'm on router 3. I'll write the access list. Access list 6. Permit 6.6.6.6. Host. Access list 7. Permit host 7.7.7. Right. Access list is written. What is next? Next is, if it is 6, I need to set community 100:100. So 2 route maps I'm going to write. I'm going to write route map for R1. I'm saying match IP address 6. If it matches for R1, what we are going to say? 100:100. Set community 100:100. Next, I'll write another with sequence 20. Same for router 1 only. Match IP address this access list. If this matches, set community 100:50. Done. This is over. So for access list 7 we have given this lower. We need to do the opposite now. Do show run section route map. I'm going to copy this to a notepad, alter it. Oh no, you see, we said 100:100, but it is showing some big number. Here I said 100:50, but it shows big number. You know why? It's an old format. We need to type IPBGP community new format. Now I'll type this command. You will find the easy way to understand 100 and 50. So I'll copy this to a notepad now. What is this? Copy this. Okay. Now to R2, if it is 6, we need to set 50. So I'm going to say 50 here. For R2, if it is 7, I need to say 100. Then the opposite is done. Now enable config end write memory. I need to paste this on router, same router 3. So router 3 now will have 2 class map with 2 sequence number each. Show run, you see, section route map. You see, towards R1 for 6.6.600, whereas towards R2 for 6 we are sending 50. 7 opposite. Now let us go and attach these route maps to the neighbor. Router BGP 300 neighbor 13.13.1 13.13.0.1 use the route map for R1 while you advertise out. Likewise, neighbor 12.12.02, use the route map for R2 out. Oh no, I think the IP address is 23, not 12. 23.23. Clear IP BGP star soft is no use. Why, you know? I did not say send to community. I have to say that also. Router BGP, unless you say send to community, it will not send. Router BGP 300 to this neighbor, send the community, and to the other neighbor also. Sorry. All right. Over. So now advertisement is sent along with the community value. You can check it there. Go to R1 and check. Show run. No run. Show IP BGP 7.7.7.7. You can see the community value. Likewise for 6.6.6.6, you see the community value. But the community is old format. Let us change it to new format. What? What?
Community values got changed.
Not changed. It's an old format. We need to put this command IP BGP community new format. Now you check, it will not be changed. How it is changed? Listen. Show IP for 6. Listen. 600. How it is changed? 600 only we set there. For 7 we set 50. What change you see here? What?
Yes, sir. Got it.
Okay. So we are receiving with community. Let us also check it on router 2. Show IP BGP for 7.7.7.7. I should see 100:100. Okay, new format. IP BGP community new format. Now you see 100:100. For 6.6.6.6 it is 50. Now no action will be taken because the local preference is still same. We have to now match this incoming community value and set local preference. Let's do that. I'm on router 2. IP community list 1. Permit. The community value is 100:100. IP community list 2. Permit 100:50. Now I'm going to paste the same on router 1. So we have mapped to 1 and 2. Next is I'm going to say route map. from R1. Match community 1. If community 1 matches, set local preference 1000. Sequence 20, match community 2. If this community 2 matches, set local preference 500. Now I need to paste this one also in router 2. Do show history. So only the route map name I will no need to change. Okay, I should have said name as 3, but I mistakenly have said 1. It is okay, name doesn't matter. But on the notepad I'm going to correct it. I'm going to change it as 3 and I will remove the 1. Why to have confusion?
It should be not from, it should be to R.
No. Update is coming from. Route update is coming. From where these updates are coming? It's from router 3. As it comes in, it injects this local preference. So I'm going to paste this on both the router. On router 1. Yeah. Thank you. Alright, so let me paste this first on router 1. And now on router 2, you don't need this line. On router 2, we have pasted the same. Okay, what is next? Next is attaching to the neighbor. Router BGP 124. When the advertisement is coming from neighbor 23.23.0.3, use the route map from router 3. As it comes in from router 3, update. Clear IP BGP star soft. Likewise, router BGP 124, when we receive update from, what is that, 13 I believe, 13. Use the route map from R3 as it comes in. Clear IP BGP star soft, show IP BGP 7.7.7.7. You see the local preference is set to 500. Whereas on router 2, it is 1000. For 6.6.6.6, it will be opposite. For 6.6.6.6, this is having 1000, whereas the other one is having. Okay, other one is not shown. Now let us trace route and see. That's the best place. Go to R4. I was telling you earlier, this should be 2. Check it. Yes, we have achieved it. For destination 7, it will go via router 2. For destination 6, it will go via router 1. If you ask why, show IP BGP will show you. It shows why. It says for 6.6.6.6 gateway 1 has got high local preference. For 7.7.7.7 gateway 2 has got high local preference. That's it. On router 1, if you check the same output, show IP BGP, you can see that 500 for 7 from router 3, while as going to router 2 is 1000. Alright, next, what is next? Trace route and test. Trace route from router 4. Trace to go to 6.6.6.6 source. Tell me which path it should take, 1 or 2? Why you are saying 2? 1000 is given for 666 on router 1. So it goes via router 1. When you trace route to 7, it goes via router 2. So we have a very good example here for BGP community, and go through this video 2-3 times. I'm sure you will not able to do immediately after this class. You need some more time to analyze those steps, why we type, where we type, and then you will understand better. Then you go and do the lab. First you watch this video twice or thrice. I'll take the doubts. If you have doubts, I'll take the doubts in the next class. See you in the next class. Take care.